All right, guys, now that we have a good idea of what makes up a firm's revenues, what makes up a firm's costs, now we can talk about maximizing profit, okay? And I'm gonna go through a simple example to kind of explain the rule to you of where a firm wants to set its output in order to maximize its profit. And I'm gonna do that by imagining that you are producing something pretty simple, okay? Little Matchbox cars, right? Or these are probably Hot Wheels, actually. I've been trying to figure out ways that I could work in some of my kids' toys into these videos, and so I finally have a good excuse to do that. So what I'm going to do is talk about producing a particular car. We're going to look at what is the marginal cost of producing that car, compare that to the marginal revenue, and think about how much extra profit the firm is earning. Okay, now here with the marginal revenue, remember we're sticking with this idea that you're in a competitive market. So there's just one price for every unit that you sell. And so that price is your marginal revenue on every unit. And it doesn't matter how many of these things you sell, you're going to be able to maintain the same price. Marginal cost, I think it's also important to point out this marginal cost number, it's going to include our opportunity costs. What else could we have been doing with our resources instead of producing this particular unit? And then this extra profit, that means it's going to be the extra economic profit that we would earn from producing that unit. And what we're going to do is I'm going to introduce each unit individually, and we're going to think about, do I want to produce that next unit or not? Would it add to my profit to produce that unit, or would it not add to my profit? Would it perhaps subtract from my profit? So, first unit, let's assume that the marginal cost of producing it is 50 cents. Okay? If that is the marginal cost, and the marginal revenue of producing that unit is $2, then my extra profit is going to be the difference between those two. $2 minus 50 cents is an extra profit of $1.50. So do I earn additional profit by producing that unit? I do. So I'm going to want to produce that unit. Okay, now introduce the second unit. Unit number 2, we'll say that now my cost of production goes up on that unit. Let's say it cost me $1 to produce unit number 2. Well, compare the dollar to the extra $2 that I would earn by selling that unit, and you can see that my extra profit is once again going to be positive, and it would be $1. $2 marginal revenue minus $1 marginal cost gives me that economic profit. And so once again, yes, that's a unit that I want to produce. Third unit. Let's say that now the marginal cost has gone up again. This one's going to cost me $1.50 to produce, but I can sell it for $2.50, which is more than the cost, and so my extra profit will once again be positive. $2 minus $1.50 gives me economic profits of 50 cents. So once again, I want to produce it. Now, introduce car number 4. This fourth car will say that the marginal cost has gone to $2. Marginal cost is $2. Marginal revenue is also $2. So if I produce this unit, I'm making 0 in my extra profit. Okay? Do I want to produce this unit or not? Well, the key here is to remember that this marginal cost includes my opportunity costs. So even though my extra economic profit is $0, this means that I'm making as much profit producing that unit as whatever my next best alternative would be using the same resources. Okay, so it's not that I'm necessarily making 0 on this unit. It's just that when you account for my opportunity cost, I'm making as much profit on this unit as my next best alternative. So an economist would say, yes, you should produce that additional unit, okay, in order to maximize your profits. And also, just to think more simply than that, you could say, well, if you're exactly breaking even, that's the last unit that you should still be willing to, okay, because you're not losing any profit by producing fewer than that. Now, let's introduce car number 5, the last one that we have space for on this sheet of paper. And you can probably see where this is going. Marginal cost has been increasing by 50 cents on each additional car that I produce. And so I'm going to maintain that pattern and say $2.50 would be the marginal cost of producing this car. My marginal revenue is $2. And so if I produce that unit, I'm going to have a negative extra profit. It's going to cost me 50 cents more to produce this than if I don't produce it. Okay? And so we would say no. We don't want to produce that fifth, and in that case, this case, final unit. Okay? So why would that be the case? Notice that as the extra profit adds up with each additional, if I was counting up my total profit, if I sell 1 unit, it's $1.50. If I sell 2 units, I'll earn $2.50 in additional profit, or in total profit. If I sell 3 units, then this is going to go up to $3 of profit. If I produce the 4th unit, I'm still at $3 of economic profit. But as soon as I produce the 5th unit, now I'm losing profits from what I had been totaling. So instead of $3, I would take that $3 in economic profit and subtract out 50 cents. I'd only be making $2.50 again. And so there's no reason to produce any units where the marginal cost is greater than the marginal revenue. But there is a reason to keep on producing, to keep adding to my output as long as marginal revenue is greater than marginal cost. And so that means you're going to maximize profit by continuing to produce until marginal cost is equal to marginal revenue, right? And so you can see marginal cost is less than all these units, than marginal revenue on all these units. Yes, you want to keep producing. Marginal cost is equal to marginal revenue. Yes, produce it. Then you want to stop, because if you produce 1 more unit, the marginal cost is greater than marginal revenue, and you're going to be chipping away at those profits that you had been earning so far. Okay? So that car we wouldn't want to produce. These 4 would be the only profitable cars that we could produce. All right, so now let me move on to a bit drier of an example of this. This is going back to your textbook, and it's combining the tables that I've already shown you in the last couple of videos, the cost and the revenue tables. It doesn't have every single cost, but I do have the total revenue and total cost figures here, the marginal revenue and marginal cost figures, and then in between here we've got the total profit. How much profit would I earn in total if I produced a given quantity? And then down here we have what would the change in profit be if I produce that extra unit. Okay, so to simplify things, or to focus, I'm going to hide most of this. And we can just take a look. Do I want to produce no units? Well, my total cost would be $30, total revenue would be 0, and I'm making negative total profit. So that's a hint that probably I don't want to produce nothing if I've gone through the trouble of taking on these fixed costs of purchasing the building or taking out a loan, etc. What about this first unit? Do I want to produce it or not? And do I want to keep on producing? Well, notice that here the marginal revenue is $50. Marginal cost is $4. So the marginal revenue is greater than the marginal cost. Yes, I would want to produce that unit. And that doing so would bring my total profit up from negative $30 to positive $16. Unit number 2. Once again, I can compare marginal revenue to marginal cost, and I can see marginal revenue is greater than marginal cost. So that says, yes, produce that unit as well and keep going. And notice that my total profit will have increased again from positive 16 to positive 60. And you're going to find as you go down the list, marginal cost greater than marginal revenue greater than marginal cost. That's true here. That's true here. That's true here, and so on. And now I reach this point in the table. On the 8th unit, marginal revenue is equal to marginal cost. And notice that all the way up to this point, my profits, my total profits have been increasing, right? They've been getting bigger. And you can also see that the change in profit. I earned $46 more by producing 1 unit than 0, 44 more by producing 2 versus 1, and so on. Once I get to this 8th unit, change in profits, in economic profits, is 0. So I've produced everything that's profitable to produce. Now it's time to stop. If I were to produce an additional unit, the marginal revenue would be less than the marginal cost. And notice that my total profit would drop. It would go down by $40. So I wouldn't want to produce unit 9. And similarly, unit 10 would be even more foolish to produce because marginal revenue is even smaller relative to marginal cost than it was on a unit number 9. So once again, where you want to produce is right here. On unit 8, where marginal cost equals marginal revenue. So that's it in table form. Now let's talk about in graphical form. Now, you'll see that I have 2 graphs here. The graph on the left, this comes out of the textbook, and I have a version of it in my lecture slides. But I've also got a slightly different graph to the right. The only difference between these 2 graphs is the shape of the marginal cost curve. In the Marginal Revolution University video that goes up, they show a marginal cost curve like this. Starts at 0, goes up slowly, and then starts increasing steeply. So it's getting costlier and costlier to produce each additional unit. Now, it's possible that a firm would have a marginal cost curve that looks like that. But it's also possible for a firm to have a U-shaped marginal cost curve. What would this tell you? This says that the firm is getting more and more efficient at producing units as it ramps up production. It's actually getting less and less costly to produce each additional unit until you reach some minimum point. Okay, so at some particular level of output, you're operating at the minimum of your marginal costs. But then, as you ramp up beyond that point, you start getting less and less efficient at turning your inputs into outputs, and it starts getting costlier and costlier for you on each unit that you produce. Either of these 2 graphs is going to produce the same overall outcome, but your textbook, I believe, only gives you this case, and it turns out that this can be relevant in some cases as well. So I want to show you, these graphs under both circumstances. All right, so in table format, what we were doing was we were looking at marginal revenue, marginal cost, and wherever there was a positive difference between the 2, we said keep on producing, right? And that was unit number 1, and unit number 2, marginal cost is a little closer to marginal revenue, and unit 3, marginal cost is a little closer still. And as you produce more and more units, marginal cost catches up to marginal revenue, and you end up this point right here, which I will call Q1. That's where marginal cost is equal to marginal revenue. And notice that if you produce those units, then the firm is earning profits that can be represented by the area between these 2 curves. The difference between the price that you sell a good for and your marginal cost of producing that good. It's going to be this area right here. That'll be your profit. Okay. Now, you don't want to stop producing before you hit this point where marginal cost equals marginal revenue, because doing so would eliminate some of those profits that you've earned. If I cut back on my output, I'm giving up some of those economic profits that I could have been earning. I don't want to do that. So I want to keep on producing. Okay, but notice once you hit Q1 here, if you keep producing more, those new units, it's going to cost you more to produce them than you could sell them for in the market, which means if you were to produce extra units, you'd start taking on losses, right, equal to the difference between the marginal cost at which you're producing and the marginal revenue that you can earn. All right, so you don't want to do that. You want to stop here where marginal cost equals marginal revenue. What about over here? Well, notice that rule that I gave you, marginal cost equal marginal revenue, it's true in two places on this graph. Right here, marginal cost equals marginal revenue. Right there, marginal cost equals marginal revenue. Okay, so that simple rule, marginal cost equals marginal revenue, doesn't give you all the information you need if the marginal cost curve is U-shaped and the marginal revenue curve hits it at two different points. Where do you suppose that we should stop producing? Well, notice that if we stop here, every unit that we've produced has cost us more than we earn, right? The marginal cost on those units is all greater than the marginal revenue. So we would be earning losses on those units. And then you'd stop, if you stop producing there, you make no profit at all. Once you have produced that many units, though, and you get to this point where marginal cost has fallen below marginal revenue, now you're earning profit on all of these units. And so if you kept producing to this point, call that Q1 on this graph, then you would make these profits that you could set against those losses, right? So yes, you would have lost money on the first few units, but you'd make profit on all of these other units. Now, so obviously you don't want to stop here because then you don't get into the good part where you're making profit. And you don't want to stop producing before this point, right? Because then you're giving up profit on units that you could have made a profit on. But similarly, you don't want to keep on producing past that point Q1, because if you produced a little bit more, then the cost on those units would be greater than what you could sell them for. So you'd be making losses again. So clearly, you want to produce at this point here, okay? So the rule is, there's actually two rules for maximizing profit. First rule, which if you're taking a calculus class, we would call it your first order condition, is that marginal cost must be equal to marginal revenue. And the second rule is marginal cost is rising, okay? Which is just a simple way of saying that marginal cost has a positive slope. If you took the derivative and plugged in this Q1, you would get a positive number. Okay, so marginal cost equals marginal revenue, and marginal cost is rising. Notice that's true at both of these 2 points where we're maximizing profit. Okay, so wherever that market price is that determines your marginal revenue, a firm's going to look at that price, keep producing up to the point where marginal cost is equal to marginal revenue, and stop producing once they hit that point. Now, suppose that something happens in this market that increases the price, which we'll assume for the moment is due to like an increase in demand. Okay, well, in that case, if the price gets pushed up, that would be represented by a second marginal revenue curve. Call that MR2. Notice that now that you have pushed the price up, the firms can now afford to produce these extra units. They can make a profit selling these additional units. So you would take now a new line down here to Q2. Same thing here. Q2. With that increase in price, now there's extra profits to be made if the firms increase their output. Okay. Similarly, if you were to cut this price, it's going to the marginal revenue curve is going to intersect the marginal cost curve at a lower level of output, and so the firms would shrink. They would reduce their output. Okay. So this is kind of a graphical illustration of maximizing profit. Then we're going to go through one last page, and that is a way of showing profits and losses that are simple geometrical shapes, okay, showing them as rectangles, because you could calculate the area of this profit, okay, or over here you could calculate the area of this loss, the area of that profit, and then find the difference between the two. But to do that, you would need integral calculus, okay? You'd need to have the function that gives you that marginal cost curve, the function that gives you marginal revenue, and run an integral or integrate the difference between those two functions to find the area between them up to the level of output Q1, okay? That's a lot of work for a simple economist to do. And so at this level, at the principles level, we instead, we're going to complicate these graphs by a little bit, but that's going to make it simpler to represent profit on the graph. All right, so here is how we do that. Here we had a marginal cost curve and a marginal revenue curve. On the next graphs, we're going to introduce a new curve, which is the average total cost curve. Now, the MRU video and your textbook, they don't refer to average total cost, they just refer to average cost. But since that average cost is, as we'll talk about in a later video, this is equal to the sum of a firm's average fixed and average variable cost, I like to call it average total cost. And in this video, I'm not going to go through a big long ordeal on why the average total cost curve is shaped this way. They do a pretty good job of explaining that in the MRU video. Basically, your average fixed costs keep falling as you produce more and more units, and that effect is bigger when you're producing fewer units. But your average variable costs tend to get bigger, at least eventually, as you produce more units. So eventually that effect takes over and pushes the average total cost curve up. Another thing to note is the marginal cost curve is always going to start below average total cost because your marginal costs don't include your fixed costs. So it'll always start below. And marginal cost oftentimes does shrink like this. Wherever it crosses the average total cost curve, that's going to be the minimum of the average total cost curve. And that's because the marginal cost, as long as the marginal cost is below the average cost, it pulls the average down by more, okay? And even as the marginal cost curve is increasing, as long as it's less than the average, it's still pulling the average down. When the marginal cost of the next unit is above the average, it starts pulling the average back up. So the only place where the marginal cost and average total cost can be equal to each other is where average total cost is at its minimum. As soon as marginal cost goes above that, the average is going to start coming back up. If the marginal cost is below that, the average will again go back up as you get rid of units that were pulling the average down. Okay, so that's the long and the short of it. If that was confusing to you, don't worry about it too much because that is not going to show up on an exam. And if you want to talk to me about it during office hours or something, I'm happy to do that. Here's the point. You've got the average total cost curve, and when you combine that with the marginal revenue curve, that's going to allow you to draw the profit or the loss that's being earned in this market as a simple rectangle. Okay, so in the profit case, we're going to set the price of the good pretty high. Okay, we'll put it up here. I'm going to call that price P1. Now, what do we know from what we've learned so far about profit maximizing? How many units is this firm going to produce? Well, this firm is going to want to produce on every unit where this price, which is also the marginal revenue, every unit where the marginal revenue is greater than the marginal cost, the firm's going to want to keep producing. And so that's going to stop being true here, where marginal cost equals marginal revenue. So the firm will produce, call it Q1 units. All right, that's the number of units they're producing. Now, this average total cost curve, what does it do for you? It allows you to take a quantity of units, plug it into the average total cost curve, and figure out how much is it costing this firm per unit to produce this many units. Okay, so that's the average total cost. If I find the difference between the price that I'm selling every unit for and the average of what it costs to produce every unit, that line segment right there, that tells me the average profit per unit. So that distance shows me the average profit. If I take that average profit per unit and I multiply it by that quantity of units, that is going to give me this rectangle that's bounded above by the marginal revenue curve. It's bounded below by the average total cost per unit, this line that I just draw back to the y-axis. And the difference between the price I get to sell at and the average cost per unit, if I multiply that by the Q units that I'm able to sell, that's going to give me my profit. And notice that these are economic profits. I'm assuming that my opportunity costs are included in the marginal cost and average total cost curve. Okay, so that's how I can graph the profit of this firm, average profit. And let me put, that's the average profit per unit, is that distance. Okay, so that's what profit looks like. Loss is going to look the same, but in order to have a loss, the firm is going to be needing to produce at a price that is less than the average total cost. So I'm going to draw a new marginal revenue curve, but I'm going to push it down below the minimum of the average total cost curve. Let's put it right, let's say right there. Actually, I'm going to push it down a little bit more to make the rectangle more obvious. So call this price P2. That gives me my marginal revenue curve MR2. And where is the firm going to want to produce? Well, it's not going to want to produce that many units because they'd lose money on all of them. So it would keep going until you hit marginal cost equals marginal revenue, with marginal cost increasing. So the quantity of units would be down here at Q2. Okay. Now, how do I show the losses? Well, this point on the marginal revenue curve, I'm selling all the units at the same price. So that's the price per unit, or the average revenue per unit. If I take that quantity and I plug it into the average total cost curve, I can see that my cost per unit is up here above the price I can charge. And so the distance between those two is going to be the average loss per unit, just like it was the average profit per unit over here. That's going to be my average loss per unit, that distance. Now, once again, if I take this average total cost and I draw a line back to the y-axis, I get a rectangle, although in this case it's a much smaller rectangle. And that rectangle represents my loss from operating in this market. Okay, so it's going to be that rectangle that I've marked in red. All right, so that is it for this video. Remember that the rule is, even though the graphs are not particularly simple, the rule is simple. The firm wants to produce where marginal cost equals marginal revenue and marginal cost is rising or marginal cost is increasing. And given that, you can represent graphically the profit or the loss on the graph by finding the distance between the price I can charge and the average cost per unit, drawing straight lines back to the y-axis that rectangle is going to give me either the profit or the loss. All right, so that's it for this video, guys. Thanks for watching, and remember to be flexible, communicate, and stay awesome.